In this lecture, we're going to explore the copy assignment operator. And this is an operator that allows us to copy an object into another object. Suppose we have 2-point objects as we see here. We have P1 and P2, and we want to assign P2 to P1. What this is going to do is going to assign each member variable from P2 to the related member variable in P1. So this is going to assign mx from P2 into mx in P1, and we're going to take my in P2 and assign that to my in P1. If we happen to have any pointer member variable and we happen to have done dynamic memory allocation, if we don't do any custom assignment, this is going to do shallow copy. If you remember what shallow copy is, it's just going to blindly copy the pointers, and it's going to assign the pointer in P2 to the pointer in P1. So we're going to do something like this, and now these two guys are going to be pointing to the same location. P1 and P2 are going to be pointing to this location here, and this is bad. As we have seen in copy constructors, we don't want this. That's why you might want to do your own copy assignment operator. And one thing I should tell you up front is that if you don't have a custom copy assignment operator in place, the compiler is going to generate one for you. And the compiler generated one is going to do member-wise copy, which is what we just described. It's going to just blindly copy each member variable from P2 into P1. And for pointers, this is going to do shallow copy, and we don't want this. This is one reason we might want to do our own copy assignment operator. So let's see how we can do this. If you want to do your own copy assignment operator, this is the syntax you follow to do this. You are going to set up your own return type depending on how you want this to work. You are going to say operator equals, as you see here, and then the right operand is going to be what you want to specify as the second parameter here. And another thing I should point out here is that the copy assignment operator can only be done as a member function. So C++ doesn't support doing this as a non-member, and if you try to do that, you're going to get a compiler error. Once we have the header in place, we're going to jump into the body of the function here. And you see that we are trying to do a self-assignment check. We are trying to see that what we have on the left is different from what we have to the right. And I am going to try and explain this in a little while. For now, let's just see how we do our own assignment in the body of this if statement. We are just going to copy things from the right operand and put them into the left operand, which happens to be this current object because it's going to be our left operand. This is going to be the same case for each operator you overload as a member function. The current object is going to be the left operand. I hope you remember that. So we're going to copy data from the right operand and paste that into the current object, if I can say it like that. So we're going to copy mx from the right operand and put the value in mx. We're going to grab the data for my from the right operand and put that into our my member variable. After that, we're going to return this because we are returning by reference. And by the way, we are returning by reference here because we want to support chained assignment, as I am about to show you in a minute. So this is the syntax we're going to follow, and once we do this, we're going to have our own copy assignment operator, and this is going to work as we expect. Once we have this in place, we will be able to do code like this. We have 2-point P1 and P2. We will be able to do assignments like this. So if you look here, we are assigning point 3 to point 2. After that, we're going to take what we have in point 2 and assign that to point 1. The result of this is going to be that we're going to have the same data in point 1, point 2, and point 3, and the value is going to be what we had in point 3, and we're going to see the same results printed out if we print these things on the output stream in these 3 stdc out statements here. We're going to see this when we hit Visual Studio Code in a minute. One thing you need to be careful about is that the piece of code like this is not going to call the copy assignment operator. And one might think that because we are using the assignment operator here, this is going to call the copy assignment operator. But watch your steps. What we are doing here is construct a 0.5 object. So this is going to call the copy constructor. We are going to be constructing 0.5 from 0.4, and this is going to call the copy constructor, and you need to be aware of this. The copy assignment operator is only going to be called if you are cross-assigning between objects that already exist. Okay, so if we come back to our earlier example, you're going to see that here we are doing an assignment, but 0.1, 0.2, 0.3 are objects that already exist that were built and set up beforehand, and we are just doing an assignment here. So this is going to call the copy assignment operator, but what we have here is going to call the copy constructor, and we're going to prove this in a minute when we hit Visual Studio Code, and you should keep this in mind. Okay, so now that we know this, we're going to come back to our copy assignment operator and analyze why we need to do a check for self-assignment. And here we have a simple example of self-assignment. We have a 0.4 here. Inside we have 40/40. And we might do an assignment like this and assign 0.4 to 0.4. And I know what you might be thinking. Why would I do something like this? And I agree with you, chances that you do this are very slim. But you never know, because in large code bases, you might do this by mistake and it is going to bite you, especially if you are doing dynamic memory allocation. Let's look at a simple example. Here we have a copy assignment operator done for our point class. It is right here. It is what we just described earlier, and it is going to do deep copy. So if you look down in our member variables, you're going to see that we have a pointer member variable now called SumData. And in our copy assignment operator, we're going to be smarter and not do shallow copy for the pointer member variable. So what we're going to do is try and dynamically allocate memory in the object where we are doing the assignment. So that's what we're going to do right here. And we're going to do dynamic memory assignment and put the data from the right operand in our newly allocated piece of memory here. After that, we're going to do member-wise copy for our non-pointer member variables. This is going to work just fine. And then we're going to return our current object because we are returning by reference to be able to support chained assignment. And this is good and right. But if you do self-assignments, let's try and analyze what is going to happen. But before we do that, let's look at a case where you are not doing self-assignment. So this is going to copy P2 into P1, and for our pointer, the general flow is to release memory in P1 because that's where we're going to be copying data into. We don't want to be pointing to the same thing as in P2. So what we're going to do is release the memory we have in P1, and we are going to allocate a new piece of memory for P1. And what we're going to do is copy the value we have in P2. So we're going to grab the value we have in here, and we're going to store that in our new memory location. But notice that we had destroyed what was in P1 and copy over what we had in P2. This is the general flow. But if we are doing self-assignment, this is going to be disastrous. This is the setup we have here. Again, this is going to be calling the same copy assignment operator we had described earlier. In this case, we're just going to be copying P1 into P1. So this is a self-assignment. And the same thing is going to happen. We are going to try and release the memory in the left operand, and this is going to release the same memory that P1 and P1 are pointing to. So these are exactly the same objects. And we are going to allocate new dynamic memory. So we're going to allocate a new piece of memory in the left operand, but we're going to try and copy the data we had in the right operand into the newly allocated piece of memory in the left operand. And this is going to try and copy from a piece of memory that we have already released, and this is disastrous. This is going to probably cause a crash, and if it doesn't give you a crash, it's going to just copy junk data that you don't really intend to have in P1, and this is really bad. So this is why we need to do self-assignment. We don't want to do this, and in our copy assignment operators, we want to do a check like this. We want to check and see if the left operand is not the same object as the right operand. And only then do we do our copies as we are doing in here. And if we have some pointer member variable, we're going to allocate for new space within these curly braces. And this is going to be much safer. Now that you know this, we're going to head over to Visual Studio Code and play with this a little more. Okay, so here we are in our working folder. The current project is copy assignment operator. This is what we want to do. And we are going to grab the code from the last lecture. I think that's going to be much better because we're going to have the point class already declared. So we're going to copy this and we're going to put this in our current project. And don't forget to copy over the VS Code folder because this is going to give us the settings we need to do this project here. So let's copy this. Okay, so let's open this in Visual Studio Code by dragging and dropping here. This is going to open our little guy, and we can clean up the main function because we might have things we don't need in place. Let's take this out. And we're going to look at our point class here and remove some of the things we might not need. I don't think we need these plus, plus, and minus operators here. So we're going to remove them because they are just going to be confusing us here. And we can remove these declarations we have below. And we can head over to the .cpp file and remove these guys. We can do this. And this is going to be a good starting point for what we want to do in this lecture here. So the first thing I'm going to do is show you that we can actually do cross copies even if we don't have any copy assignment operators in. And this is going to be using the compiler generated copy assignment operators. So we're going to set up another point. We're going to say point to P2, we should say, and we're going to put 2020 in. Why not? And down here, we're going to do an assignment. So we're going to do P2 equals P1. And what this is going to do is do a member-wise copy from P2 and copy all the member variables into P1. So it is going to grab mx in P2 and copy that into the mx member variable of P1. It is going to take the my member variable in P2 and assign that into the my member variable of P1. And this is going to work. So let's try and build this program and see what we have in P2 and P1. We're going to do stdc out and say P1. We're going to print these out. And we're going to do stdc out P2. And we're going to put this on the output stream. We're going to say stdendl to put our new line character in place. And we can copy this and use this before we do our assignment here. And we're going to put a separator between these two. We can do this. We're going to put a bunch of dashes here. And this is going to do good by us. Okay, so we have this in place. We can build and run this program. We're going to use GCC to do that. And the build is good. You see that the syntax here is working even if we don't have any explicit copy assignment operator declared in this class here. And this is going to be using the compiler generated copy assignment operator. And this is really cool. If you only have non-pointer member variables in your class, the compiler generated copy assignment operator is going to work just right. You don't have to declare it in your class, and this is really cool. So we are going to bring this up and run our program. We're going to bring in our PowerShell window, and we're going to clear and run Rooster. You're going to see that on our first print, we're going to print the data we have in P1 and P2, and that happens to be 1010 and 2020. But after we do the assignment, we're going to copy the data we have in P1 and put that in P2. So P2 is going to change to 1010, and that's what we see down here. So our copy was successful, and again it was using a compiler generated copy assignment operator. But this can be disastrous, because if we have a pointer member variable and we happen to be dynamic memory allocation, this is going to blindly copy the pointers, and after you do your copy, the 2 points are going to be pointing to the same data. And let me show you what I mean here. So to show this, we can put in a pointer member variable. Let's do this. We're going to say int pointer and say pdata. Exactly what we had in the slides. And in our constructor, we're going to do some modification and put in an int parameter that we use to initialize our pointer. So what we're going to do here is put in a variable name called data. This can work. And then we're going to initialize our pointer in our initializer list here. Let's do this on the fly. And this is pdata. Let's be consistent. And we're going to say new int, and we're going to put in our data and initialize our pointer here, and this should work. Okay, so now we are doing dynamic memory allocation in our constructor here, and we are initializing our new memory location with the data that we have in our parameter list here. Now, in the main CPP file, in our main function, we're going to change our points here. So if we create them, we're going to put in our data. Let's say we put in a 10, and we're going to put in a 20 for P2, just to be consistent with what we had done before. And I think we will need to modify our output stream operator to also print the data we have in our pointer member variable here. So we're going to go down and put that out. We're going to say data. Here we're going to say data, and we're going to take out this square bracket, and we're going to put the data out. Let's put this to the next line so that we can see this easily. And we're going to dereference our data and print this out, and then we're going to put our closing square bracket, and we're going to say pdata here. This is our pointer, and we're going to dereference that and print the data that we have inside. I think this is going to work. And let's try and build this to see if our compiler is going to take this. And we have problems. Pdata was not declared in this scope. What is the problem here? This is not a member function. So what we need to do is to dereference the member variable of point p, which we are passing as a parameter here. So here we need to say p and say pdata. This is going to go in and grab our member variable. Then we're going to dereference that. I think this is going to work much better now. Let's rebuild and see that this is actually making sense in the eyes of the compiler. Now we are fine, and we should be able to print our guys in the main CPP file. And if we print now, did we build successfully? Let's rebuild again to make sure. And if we run the program now, the build is good. We can clear and run Rooster, and we're going to see that the data is 10 for P1, and the data is 20 for P2 before we do any assignment. But after we do the assignment, we're going to see that the data is 10 and 10, and you might think that this is okay. But after this, if you happen to change the data, let's go in and put in a setter that is going to modify the data in our point object. So we're going to say void set data, and we're going to say int data, and we're going to go inside and modify our data. We're going to dereference our pdata pointer and assign the value inside. We're going to put our data in our object here. Now, if we go in our main function and do another setting to our data, we're going to say change data. And we're going to, for example, change the data in P1. And we're going to change that to 55. And if we print again, we're going to grab our separator. Let's do this. We're going to put in a separator, and we're going to put in our output streams. We're going to see that even if we set the data for P1, P2 is going to change as well. Because we have already copied pointer addresses when we copied our data member variable, because the default copy assignment operator is going to be doing shallow copy. So it's going to be blindly copying the addresses we have in our pointer member variable here. And if we build and run this program, we're going to build with GCC as we always do. The build is going to be good, but if we run, you're going to be surprised by the results that you see. So we're going to have our program here, and we're going to print P1 and P2. Initially, this is going to be 10 and 20, the data. After we do our assignment, we're going to have 10 and 10, and this is going to be good. This is what we expect. But after we change the data, we expect to only change the data for P1. Okay, so after we change the data, P1 is expected to be 55, but notice that P2 has also been changed. Because what we have really done is blindly copy the member variables, and we have also blindly copied the address in our pointer member variable. Hopefully you can see the problem here. And this is the reason why you might want to do your own copy assignment operator to fix this problem and do a deep copy if you happen to be having pointer member variables here. So we're going to fix this problem, and we're going to set up our own copy assignment operator. Let's do this. We're going to go on top and put this in the public scope of our class. And we're going to be exactly using the syntax we saw in the slide. So we're going to return a point object by reference because we want to support chained copy assignments. And this is going to be operator equals, and it's going to take a const point by reference because we're not going to be modifying that point. We're just going to be copying data from it. So that's going to be okay. We're going to call it P. And this is not going to be a const member function because it's going to be modifying our object. So once we hit the body, we're going to do a self-assignment check. And as we have seen in the slides, self-assignments are bad, especially if you have pointer member variables like we do now. So what we're going to do, we're going to check if the current object is not equal to the right operand. And we're going to say if. And what we're going to do is check the memory addresses for these objects. If they happen to be living at the same memory addresses, then they are going to be the same. So we're going to say this. Remember that this pointer stores the memory address of the current object, and we're going to check and see if the current object is not equal to the address of the right operand that we have passed here. So we're going to say P, and I think we should call this right operand to make it self-descriptive. So let's do this, and we're going to do the same thing here. This is going to be much better. And if they are not the same objects, we're going to know that we can safely copy the data because they are not the same objects. So we're going to go down and do a copy for our non-pointer member variables because we can directly copy them. This is not going to be a problem. So we're going to say mx equals right operand mx. This is going to do. And we're going to say my equals right operand my. This is going to also work, no problem. So let's do this. But we have a pointer member variable, and we have to remember to do proper dynamic memory allocation and not have these two objects point to the same memory location. So what we're going to do is release the memory we had in the left operand here. So we're going to delete pdata, and we're going to say pdata equals new and we're going to copy over the data we have in right operand. So we're going to dereference the pointer from right operand. So we're going to say right operand, and we're going to grab pdata, and we're going to dereference that and steal the value n and store that in our new memory location here. And this is going to be much better. Okay, so now that we have this n, we're going to put a stdc out statement saying that our copy assignment operator was called. I think this is going to show a nice message when we run this, and really be sure that our copy assignment operator was called. And then we are going to hop over to the main function and see that we are doing our copy here. So this is nice and cool. And we're going to comment out whatever we had before we do our copy assignment and really make it super easy to see our message from our copy assignment operator. So we're going to build again. We're going to build with GCC. The build is going to be, what is going on here? So no return statement. We're going to go back to our copy assignment operator, and we're going to see that we're not returning anything here. And we should return something because we need to return a point by reference. So we're going to just return this pointer dereferenced because we want to get to the data. So we're going to come down here and return this dereferenced. I think this is going to do what we want. Let's wait and see if the squiggly line goes away, because it should. And we're going to build again. Let's do that. Hopefully this time it's going to work. The build is good. We are fine. And if we go up and clear and run Rooster, we're going to see that our copy assignment operator was called. And this is really cool. Now we can go back in the main function and uncomment the line after our copy. We're going to see that we copied the data successfully and that we have the same data in P1 and P2. We're going to build again. We're going to do this in steps because that's going to be much easier to follow. We can clear and run Rooster. Now, after our copy assignment operator is called, we're going to see that the data in P2 was copied over in P1, and this is really cool. Now what we want to see is that if we set the data from P1, this is not going to affect the data in P2 because now they are using different memory locations. Remember, we did a dynamic memory allocation in our copy assignment operator here, and now P1 must be using its own memory location different from the one we have in P2, and the change we do in P1 shouldn't affect what we have in P2 as we had seen before. So we're going to build again to take this into account again. The build should be good. We're going to clear and run Rooster, and now you see that we have set P1 and P1 only was affected and P2 wasn't affected, and this is why you might need your own copy assignment operator, and this is really cool. Okay, now, I know some of you must be thinking the copy assignment operator is strikingly similar to the copy constructor, and that's because they do seemingly the same job. They allow us to grab data from another object and use that data to kind of set up our own object. And when we learned about the copy constructor, I don't think I showed you this self-assignment thing, but it is also possible to try and construct an object from the same object, and that's bad. So I am going to show you that here. We're going to go back to the main function, and I think we can comment out what we have in front here, because that's going to just disturb us. And let's go up and comment out everything. Okay, so now that we have this commented down, we're going to go down and show you something that is really crazy. That's trying to construct a point from that point. Let's do that. We're going to say point P3, and we're going to be trying to construct P3 from P3. And some of you might think, should this even compile? But it is going to compile. This is valid C++ code. If we try and build this, you're going to see that it's going to build, and that's why you need to also do a self-assignment check, even if you are doing a copy constructor. So we're going to go on top and set up a copy constructor in our point class, and I realize we have a forward declaration of number, and we don't need that here now, so we're going to take this out. No big deal here. If you leave this in, it's going to work, but I don't want to keep this in here. We don't need this. Okay, so we're going to go below our constructor here and set up a copy constructor. The copy constructor syntax is what we have seen before. It's just going to be the name for the class, and then we're going to be specifying the point we're going to be copying data from, and that's going to be P. This is going to do just fine. This is going to be our copy constructor. We can head over in the point CPP file and put in our implementation for that. I am just going to paste one I have lying on my drive here N, and use this as a starting point here. You notice we are copying over from P here, and we are going to check and see if the current object is not the same as the object we are trying to copy from. And remember, we are doing dynamic memory allocation for P data, and I think we should just copy what we have in our copy assignment operator. It's going to be mostly the same, so we can reuse that in our copy constructor. So we're going to grab this and put that in place here. And we're going to release the memory we have in our pointer. We're going to dynamically allocate a new piece of memory. And then we're going to steal the data from our write operand here. Here we should just say P. And this is going to do what we want. This is going to work. Okay, now that we have our copy constructor N, now the code in our main function should be picking up our copy constructor and using it. And it is going to check and see if we are not trying to construct an object from ourselves. If we detect that we are using the same object we have in our write operand here, the if statement test here is going to fail and we're not going to do anything. And this is going to be much safer. If we build this program, let's do this. We're going to pass this through GCC. And we are going to clear and run Rooster. You're going to see that the copy constructor was called for an object that contains 00 and the data is some junk data. We don't really care. What we just want to know is that we don't do any copy if we do a syntax like this, because this is just crazy. Why would you want to do this? This is going to try and construct from an object that isn't even constructed yet, and that's why we have some junk data here. This is bad. You shouldn't do this. And your copy constructors should really protect you from something like this. And a self-assignment check is going to go a long way in helping you and make your copy constructors safer. Now that we have this in place, we can actually try and see if this copy constructor can do its job and copy data and construct another object using another already existing point. Let's do this. We're going to put in 30 and 30 and 30. Can do this. And then we're going to try and construct an object from this little guy. We're going to say point. We're going to call this P4. And we're going to be constructing from P3. Let's see if this actually works. We're going to build our program with GCC. The build is good as you see here. We're going to clear and run Rooster. And you're going to see that our copy constructor is going to be called, and it is going to copy the data we have in P3. And now if we print P3 and P4, let's do that. And do P4 here. Let's do that. We're going to build and run, and we should see our data here. So the build should go through GCC here and clear Rooster. This is going to give us the same data in P3 and P4. And I think there is some lagging as we print these things out. Let's see if the program runs through the end. We're going to do stdc out and say done. Let's make sure that we don't have any crazy crashes. And we're going to build and run again. The build is good. We should clear and run Rooster. And this is running all the way to the end. It must be our PowerShell window, which is lagging for some reason. So our program is working as expected. Another thing I want you to see is that we can also construct our P4 object through an assignment. And we can do something like this. And some of you might think, because we have an assignment operator here, this is going to call our copy assignment operator. But watch your steps here. We are trying to set up a new object called P4 from P3. So this is just another syntax we have to call the copy constructor and construct P4 from P3. This is going to call the copy constructor. It is not going to call the copy assignment operator. And we can prove this by running this program. You're going to see that this is going to call the copy constructor. So the build is good. We can clear and run Rooster. And you see that this is what we see here, P3 and P4. So the data we have in P4 has come from P3, and we have successfully copied data from P3 and used that to construct a new P4 object. We can try and make sure that dynamic memory allocation was working correctly in our copy constructor. For example, we can take P3 and set data. We can do that and put in 77. Why not? And then we're going to print our data again. We're going to go down and put a separator in place. We can put in our trusty dashes here. And down below, we're going to print our data. We should see that the data in P3 has changed but the data in P4 should stay the same. This is what we expect to see. So let's pass this through GCC. And the bold is good. We're going to clear and run Rooster. And we're going to see that this is what we expect. We changed P3. P3 has changed to 77, the data member variable, but the data for P4 hasn't changed. And this is really cool. This is what we expected to see here. And this is really all I had to share in this lecture. I apologize, it's turned out to be lengthy, but copy assignment operators really deserve all this time because it is easy to make mistakes, and I had to make sure I show you everything I can show you in this lecture. And I hope you know that a copy assignment operator is what you see here. This is how you're going to be overloading it. You have to be careful about self-assignments. And the copy assignment operator is strikingly similar to the copy constructor. They're just going to be different in some aspects. The copy constructor is going to be called when you construct a new object like we do right here. And the copy assignment operator is going to be called when you do an assignment among objects that have been already set up like we do here. And because we are returning a reference in our copy assignment operator, we are returning a reference here, we can also do chained assignments. Let's show you this before we wrap up, because I don't think I showed you that. We're going to comment out what we had below here and reactivate what we had on top here. And we're going to set up a new point. We're going to say point P77. We can do that. And we're going to put in some junk data. Let's put in 3 and 3 and 3. This doesn't really matter. What I want you to see is that we can do something like this. We can say P1 equals P2 and equals P77. This is going to work. And if you print your data, let's say 77, this is 1, 1. And if you print data, you're going to see that P1 and P2 now contain the data we had in P77. We're going to build and run. The build is good. We can clear and run Rooster. We're going to see that we have 3 3s in. This is what we expect. And the main message here is that we can do chained assignments. And this is possible because we are returning by reference in our copy assignment operator. So what is happening here? We are taking the data in P77, putting that in P2, and then what we have in P2 is going to be assigned into P1. And this is possible because we have returned by reference in our copy assignment operator. Remember, we are returning a point by reference in this copy assignment operator here. I have trouble finding it. So that's the reason why we are able to do the chained assignment here. And we can actually try and simulate what the compiler is doing behind the scenes. Remember, what we want to do is assign P77 to P2, and then the result of that is going to be assigned into P1. We can simulate that with a statement like this. We can say P1, and we're going to say operator equals, and inside we're going to say P2 operator equals P77. In parentheses, we're going to say P77 here, and we're going to put another pair of parentheses. I think this is going to simulate what we want. What this is going to do is force the compiler to evaluate what we have in these parentheses first. So it's going to assign P77 to P2, and this operator is going to return a reference to P2. So we're going to take P2 and assign that to P1. And the result is going to be that the data in P77 is going to be put into P2, and then the data into P2 is going to be put into P1, and that's what we're going to see if we build and run this program now. Let's do that and build with GCC. And Visual Studio Code seems to have a problem. What is that? The build is good, so we can ignore this. We're going to clear and run Rooster, and this is exactly what we expect. The data into P77 has been propagated into P2 and P1, and this is what we see here. Okay, so before we wrap up this lecture, I want to warn you about what some of you might do in trying to simulate these operator calls here. So some of you might do P1 operator P2, and then do operator P77. I have seen some students do this, and this is not going to simulate what we have on top here. Before I explain this, I am going to run this program, and you're going to see that you're going to get what you don't expect. The build is good. We can clear and run Rooster, and you see that P2 is 2020, and we expect the data from P77 to be put into P2 and P1. So this is the result we see here. But to understand this, we really need to understand the statement we have on line 18 here. So what the compiler is going to do, it's going to take P1 and call operator P2 on it. So this is going to take data into P2 and assign that into P1. This is going to return a reference to P1. And we're going to be calling the operator equals to P1 again. So we're going to take the data into P2 and put that into P1. And then we're going to override the data with what we have in P77. So the result is going to be that P2 is not going to change. We're going to put the data 2020 into P1, and then we're going to override that with the data that we have in P77, which is 3 3s, and this is what we see here. In P1, we're going to have the data we had in P77, and P2 is not going to change, and that's what we see here. You should really understand these things. And in the statement we just did before that we have below here, we are going to force the compiler to evaluate the statement we have in this parenthesis, and then we're going to take the data we have in this parenthesis and assign that to P1, and that's going to simulate what we want here. You should be careful about this. This is really all I had to share in this lecture. Again, I apologize. The lecture turned out to be really lengthy, but we had a lot of information to cover, so I hope you found this interesting. We are going to stop here in this lecture. In the next one, we're going to see that we can actually set up a copy assignment operator that copies in a different object. For example, we can take a person, a car, a tomato, and assign that to a point object, and that's going to work. I know this sounds crazy, but it is possible, and we're going to do that in the next lecture. So go ahead and finish up here and meet me there.